Hello, class. Today is the 16th of April. We're going to record a video kind of wrapping up the rest of lesson 20 for us. So, at the end of yesterday's class, what we did is we looked at this graph of y equals f of x. It's a piecewise function. And we identified the 4 strategic points that were helpful in sketching this graph. In fact, they were so helpful in sketching the graph that I could super easily sketch the graph here and here without, well, any trouble whatsoever. I just had to plot the points and then connect them. But now we're going to, the only reason that we even have it sketched here in the first place is so that we can compare the original graph to a graph after we transform it. Part B asks us to sketch the graph of y equals 2 f of x and state the domain and the range of this new transformed function after we transform it. How can we use part A to help us sketch the graph? So we're going to compare all of the points that we have here to our new graph and see, well, how could we have gotten from these points to our new graph, and how could that have helped us? So, part B tells us to sketch the graph of y equals 2 f of x. Luckily for us, we have a little bit of a cheat sheet, if you remember correctly. We know that if I multiply my function on the outside by a number k, if that k is greater than 1, which it is, if k is 2 in this case, we're going to have a vertical stretch by a factor of the absolute value of k. So that means we're going to be stretching things vertically. In any case, what we're going to be basically doing is we're going to take our equations and we're going to plug some points into them, but then we're just going to take that point and we're going to multiply it by 2. So for my x value, if I were to do my x value of negative 5, just like what we had over here, I would have 0.5 times 5 plus 1.5. So that's going to be 0.5 times 5 is going to give me, well, technically this is negative 5. So I'm going to get negative 2.5 plus 1.5, which is going to give me 1. And we should already know that because of our graph. But we're going to take that and we're going to multiply it by 2. So let's plot that point. Negative 5, 2. And then we can keep going on for more points and more points. On and on and on and on for all of the points that we have. So if I were to do the same thing with 4, I would get, if I were to do the same for negative 4, I'd get negative 1. If I were to do the same for negative 3, I'd get 0 again. For negative 2, I'd get 1. For negative 1, I'd get 2. For my y equals 1, well, that's pretty simple. I'm just going to take this and I'm going to multiply it by 2. My y, I'm going to multiply by 2. So instead of y equals 1, I'm going to have y equals 2. So for this next chunk, y equals 2, y equals 2, y equals 2, y equals 2. This next chunk, I'm going to start at 3. So y equals 3 minus 2 will give us 1, just like before. But then we're going to have to multiply that by 2, and we're going to get 2, which is already graphed. 4, when it is 4, I have 4 minus 2, which is 2. Then when we multiply that 2 times 2, we're going to get 4. For 5, 5 minus 2 is 3. 3 times 2 is going to give us 6. Now what I can do is I can draw our lines here. And my transformed function is going to look like this. This is what my transformed function is going to look like. Now, first of all, what we can do is we can state our domain and we can state our range. Remember, our domain is our x values. So over what x values does this fall? And our range is over what y values does this fall? Well, our domain, our x values, are the same x values as our original function. Our domain is going to be from -5 to 5. -5 is less than or equal to x, which is going to be less than or equal to 5. Our range is different now. Our range is different. If I look at my lowest y value, my lowest y value is now no longer -1, it's now -2. So -2 is going to be less than or equal to y, which is going to be less than or equal to, if I look at my y value, that is my greatest y value, it is no longer going to be 3, it's going to be 6. So here's my new domain and range. But the last part says, hey, how can we use part A to help sketch the graph of y equals 2f of x? So in order to help us do that, what I'm going to do is I'm going to plot the points here. I'll plot these points in a second. I'm going to talk about, once again, what the points from part A even were. Remember, we have -5, -1. We have -1, +1. We have 3, 1. And lastly, we have 5, 3. If I were to ask us, hey, what are the points that we would use to sketch this new graph, what would those points be? Well, same as how in point A, it was all of our vertexes and then our endpoints. It's going to be the same thing here. We've got this endpoint. We have this vertex, and this endpoint. So we've got the two endpoints, and we've got where it swaps between the different pieces. Well, what's the coordinates of this point? Well, this point is going to be -5, -2. What are the coordinates of this point? Well, this point over here is going to be -1, +2. This one is going to be +3, +2. This one is going to be 5, 6. Now, hopefully, after I've written these all out, you can probably see what's so important about these points when I compare them to my original point. If I look at my x value, I've got -5 and -5. Okay, my my x value didn't change. But if I look at my y value, I started with -1 and ended with -2. Think in your head, what do I have to do to get from -1 to -2? I won't say it out loud yet. At these second points, I start at +1 and get to +2. How do I get from +1 to +2? Over here, I start with +1 and end at +2. It's the same thing. Over here, I start at +3 and end at +6. So again, how do I get from one to the other? Well, all of these have the same way in common. I have to multiply it by 2. And this should make sense to us. Because as we saw from our cheat sheet, this is going to be giving us a vertical stretch. Well, which out of x or y, which one is our vertical? Our y. So what we're doing is we're taking our y and we're going to be multiplying it by 2. So using part A, we would keep your x value the same, and we'd multiply the y value by 2, because it's a vertical stretch of 2. And this idea is going to work no matter what piecewise function I have. If I can identify the key points in my piecewise function, those should be the only points that I have to keep in mind when transforming it. Now, this was for our vertical stretch. Part C over here says, hey, what about if we had a horizontal scaling with a scale factor of 1/2? You see here, with 1/2, we're not going to stretch. We're going to kind of do the opposite. We're going to compress. So a horizontal scaling with that scale factor of 1/2 of the graph y equals f of x is going to be the graph of y equals f of 2x. Wants us to sketch the new graph and then state our domain and our range. Well, when we were doing vertical scaling, we took our y coordinate and we multiplied it by 2. Over here, however, we're doing horizontal scaling with a scale factor of 1/2. So our scale factor isn't 2 anymore, our scale factor is 1/2. So think in your head, what do you think we're going to be doing? Give you guys 2 seconds to think about it. And hopefully, you'll come to the same conclusion that I did. What we are going to do is we are going to do basically the exact opposite of what we did before. I've got my point here, -5, -1. Please ignore the bell. And instead of keeping my x the same, this time I'm going to keep my y the same. My y is just going to stay as a -1. My x, what I'm going to do is I'm going to either multiply it by 1/2 or I'm going to divide it by 2, because again, both of those are the exact same thing. We're going to multiply it by our scale factor of 1/2. So -5 times 1/2 is going to be -2.5. So let's go to our graph and let's plot the point for -2.5. -2.5, -1. So there's our first point right there. For our second point starts as -1, +1. So again, I'm going to keep My y value this time, because it's a horizontal scaling, so I only have to change my x coordinate. And my x coordinate, I'm going to once again multiply by my scale factor. So times 1/2 gives me negative 0.5. So let's plot that point. Negative 0.5, 1. Up next, we have the point positive 3, positive 1. Again, our y coordinate stays the same because of horizontal scaling. Our x coordinate, I'm going to multiply by 1/2. So I'm going to get 1.5 or 1.5. Plot that point. 1.5, 1. And one more point to go. That point is normally 5, 3. My y coordinate doesn't change, it stays as 3. But my x coordinate does change. Multiply it by 1/2, and that's going to give me 2.5, 2.5. So let's go over to 2.5, 3, and plot that point. You're supposed to be a purple dot. Now, just like before, what I'm going to do is I'm just going to connect my points. And there we go. That is my new graph. And then once again, we can talk about our domain and our range. Unlike last time, where our range changed and our domain stayed the same, this time it's going to be our domain that changes. Instead of being 5, negative 5 is less than or equal to x, which is less than or equal to 5. Now we have half the size. 2.5, negative 2.5 is going to be less than or equal to x, which is less than or equal to positive 2.5. And this time, our range, as we can see, stays the same as our original. Our lowest y value is going to be negative 1, and our greatest is still going to be that 3. So horizontal scaling changes our domain. In fact, it's going to shrink it in half. And these are technically our answers for 3 and 4. Our range in exploratory challenge 2. How does the range change when k was greater than 1? Well, our range got larger. We multiplied all of our y values by our scale factor. For our horizontal scaling, we multiplied all of our x values by the scale factor. Now, hopefully, this makes enough sense for us to be able to do and work on some of our problem set. In fact, what I'm going to do is I'm going to assign you guys the whole problem set for today's work. Now, as you look at the problem set, I don't want you guys to get intimidated by the size of it. Question 1 well, it does have quote-unquote J parts. All you have to do is look at what it's asking you and use your cheat sheet to answer all of those questions. Question number 2 is going to be similar in terms of using your cheat sheet, but then you can actually graph those functions that it asks for. Same with question number 2. Question number 2 is cheat sheet. All of these questions you can easily help answer with your cheat sheet. So with that, I'm going to close out our video here. I hope you guys have a great day, and I hope you guys have a great weekend. So your classwork/homework is that problem set. Have a great rest of your day. Farewell.